Okay, so I've given you about 5 minutes to take a look at this, and we're going to continue talking about probability, but we're going to shift into geometric probabilities. Okay, geometric probabilities, and today your assignment will be based on geometric probabilities related to geometric shapes and areas. Okay, but the question here is, if we have this roach, it's stuck in this box 10 inches by 15 inches in size, we want to know what the probability is that it'll stop in the red region. Okay, and then it says what's the probability it will not stop in the red region. So we want to focus your attention on how you calculate probability, because you guys have kind of drawn a blank, so I'm going to see if we can kind of jumpstart your thinking. Okay, what's the basic formula for probability? The most fundamental, basic formula for probability. Now I'm just going to put this up here, and I'm just going to put the probability notation, and I'm just going to put red region. Okay, and he's going to stay away from me, I guess. Good. All right, the probability of the red region. All right. What's the basic setup for probability? Who can help me with the setup? Because I first need to know, what am I looking at here? What am I looking at? All right. So when we talk about probability, all right, that basic probability formula, what is it? It's a fraction, right? It's a fraction. And to see if we can jumpstart your thinking, I'm going to put that in. What goes on top? Yes, sir? The what? Okay, he's got a number. He's got a number there. I'm not really looking for a number at the moment. I'm looking for the basic idea of probability. What always goes on top? Yes, sir. Okay, I thought you were raising your hand. Okay, yes, sir. Now he's getting warmer. He's going in a direction. Okay, typically the bigger number's on the bottom. Okay, and I'm going to go with that, though. He's giving us some ideas here, because when we get stuck, it's important that we brainstorm. Okay, and within your group, bounce ideas off of each other. Okay, that's how you get started. That's how you get to thinking about the problem. Okay, so the bigger number, and so along with what he said, then probably somebody would say, hey, the smaller number goes on top, right? But what's probability about? What always goes on the bottom? On the same wavelength or same thought process is bigger. The what? In a standard deck of cards, what number goes on the bottom? No, we're still with bigger. But a standard deck of cards, in a standard deck of cards, how many cards are there in a standard deck of cards? 52. 52 is all of the cards, right? So the total possible goes on the bottom. All right? The total possible. All right? Total possible. What goes on top then? What goes on top? Who can help me? For example, if I say, what's the probability of drawing a king out of a standard deck of cards? How many kings there are? Right? What do we call that? What's that? Okay, she said amount possible. Good. Now, that's referred to as the favorable number. Right? The favorable possible or amount possible, that works. Okay? So now what do I want you guys to do? All right, I want you to draw this. You don't have to write the text in, but I want you to basically draw this problem down. So we're talking about what kind of problem here? If it's geometric probabilities, we're dealing with perimeter, area, volume. What are we dealing with here? We're looking at what? Out of those three choices, what would you guys say we're looking at? What do you think? I'm going to go over here to Brett's group. What do you guys think? What are we looking at here? Area, volume, perimeter. What do you think? Take a guess. Out of those three, what do you think? What? No? Yes? Okay, he's thinking about perimeter. What is perimeter? Okay, the distance around the outside. Okay. All right, so that's the distance around the outside.
Oh, just inside the red region.
Okay, we're looking to see if we land in the red region. So this is an area problem. So we're actually looking for the favorable. All right, and I'm going to adjust this basic probability formula. All right, the basic probability formula is going to be the favorable area over the total area. Okay, the total area. All right, so it's the favorable area over the total area. So if you're not already writing this down and taking notes, I want you to do that right now. So get a piece of paper out, and I want you to copy down the shapes as it's drawn here. Leave the text out of it. You don't really need to know that. But currently, we're trying to find the probability of the roach, all right, stopping in the red region. Okay, that's what we're trying to do. So I need you to basically get those notes summarized so that you have something to look at when you go to attempt the homework tonight. Okay, does everybody have the shapes drawn? Matter of fact, what kind of shapes do we have here? Because if we're talking about area problems, okay, and we want to know the favorable area divided by the total area for our basic fundamental probability question, all right, what's the probability of the roach landing or stopping in the red region, then we have to know how to find the area of our shapes. All right, what shapes do we have here? All right, I need Caitlin's group. What shapes do we have here? Two basic shapes. Anybody from Caitlin's group? Yeah, we have a triangle. All right, and we have, okay, now someone said squares. Okay, so let's take a close look at that. What, to be a square, you have to have what? Okay, it's a rectangle. Why did you change your answer? The lengths are different. So it's a rectangle. All right, so copy that down. All right, copy that down. So we need to find areas here, okay? We need to find areas, okay? Now, which one's going to be the favorable area? Which shape is the favorable area here, just to make sure we're all on the same page? Which one is the favorable? Okay? You guys, what do you guys think? I heard you say, you said the rectangle. All right? Let's go to Sabrina's group. Do you guys agree? Do you guys agree that the favorable area is the rectangle or the triangle? What's the question? Go back to the question because that helps. Yes, ma'am. Yeah, it's the triangle. The favorable area is the triangle because it's red, and we're looking for the red region. Okay, so good. Now, who can tell me or remember what's the area of a triangle? How do we calculate that? Because it's been a while. We haven't really talked about areas recently. So, who can help me with that? Yes, ma'am. Okay, so help me out here. These two numbers, which ones? This one and this one? Okay, what do you call this one? Oh, that's the bottom one. Okay. Well, let's get some other groups. What do you call that? Okay, this one's the height, and this one down here is the... Okay, width, base, it all works the same. All right, so we're going to take those times each other. Now, what's the formula, though? Who knows the formula for area of a triangle? Yes, ma'am. Base times... there we go. 1/2 the base times the height. All right, 1/2 the base times the height. All right, so that's going to be 1/2 times 5 times 6. Okay, and someone said the answer already. Come over here to Emmy's group. Yes, ma'am. And what unit should I put on here to indicate that I found area? Okay, good. Inches squared. So this is 15 inches squared. 15 inches square. Okay. Let's move on to the rectangle. Who can tell me the formula for the area of a rectangle? Back to your group. Yes. She's giving us those two numbers. Okay, those two numbers. Well, describe that to me, though, in a rectangle. Who can help us out here? Yes, sir? Good enough. Length times width. Very good. Okay, and so she said multiply the two numbers. So what are the two numbers for the rectangle? What are the two numbers for the rectangle? 10 times 15. And so how many inches square do we get on that? 150 inches square. Okay, 150 inches square. All right. Now, back to the concept of probability. And this is the fundamental probability formula or ratio. It's always the favorable, right? Favorable possible, or in our case, we're talking about area, so favorable area, divided by the total area. Okay? So what are we going to do here? What numbers go where? What area answer goes on top? Help me out here. What would that be? This group over here, let's hear from you guys. Which number goes on top? Which one's the favorable? Okay, I thought I heard you say red. You're right. Which one is the red area? The triangle. So the 15 inches square goes on top. 150 goes on the bottom. And you guys take out your calculators, please, and calculate what the probability is, okay, of landing in that red region. Okay, what'd you say? Okay, he got 10%. Thank you. All right, or 0.10. So 10% of the time the roach is going to stop in the red region. Okay. Now the next question then we would have, the next question would be, okay, what's the probability of not stopping in the red? Okay. And that's a little easier question now that we know the probability of stopping in it. What's the probability of not stopping in it? What would that be? Yes, sir. 90%. And how did you get that? You just knew it. You just knew it, right? Right. What's the percent of it? What is the percent of the total percent on anything? 100%, right? And so the formula for not is always the probability of, it's always written as 1 minus the probability of it happening, okay? And this is for not, okay? So he did 1 minus 10%, or 0.10 in this case. All right. So this was 1 minus 0.10, okay? And I gave it 0.90, which is 90%, or you could have said 100% minus 90%, okay? Or, I'm sorry, 100 minus 10% is what I'm trying to say. And that was 90%, so however you want to say it. But for the probability of not, the formula is always the 1 minus probability of it happening, okay? So that's the idea behind it. So which is more likely to happen here? Based on what we've just calculated, what's more likely to happen for the roach? Yeah, he's going to stop in the white part. He's not going to land in the red region very often. Not very often, okay? Right, I know he's as he's been rolling here, he doesn't seem to stop very often. Okay, good. All right, so probability question, talking about geometric probabilities. Okay, now what I'm going to do is go to another example, and what we're trying to do is get you guys familiar with probabilities and basic geometric shapes. And when we talk about geometric probabilities, we talk about the probability of landing in shaded areas on basic shapes. Okay, so we have a polygon here. Okay, we have a polygon, and it happens to be composed of two different shapes. But for now, I'm just going to talk about the polygon issue. All right. What is this polygon? How many sides does it have? It has 6 sides. All right. If it has 6 sides, all right, what kind of polygon is that? Yeah, that's a hexagon. Good job. That's a hexagon. We just want to review that for a second because we said over here in our I can statements today that one thing's you're going to be able to identify the basic polygons, right? When we're done with this lesson, our goal is that you can identify the basic polygons, okay? Now, there's 2 other polygons there, all right? There are 2 other polygons, all right? What's the most basic polygon? It has 3 sides. Yeah, that's a triangle, all right? What family does the middle one, what's the middle shape? Anyone? That is a rectangle. What family does that belong to? A square is what part of this family? Well, thank you for saying something. Okay, a rectangle and a square. They're part of this family. Who can help me? Thank you. It's quadrilateral, right? Right. Quad is 4. Now that you're on that, who else belongs to the quadrilateral family? There's another one. We already said a square and a rectangle. There's 2 more that belong to that family. Yeah, rhombus, the diamond, right? Rhombus belongs to that. There's one other one. There's 2 other ones. There's 2 other ones. Yes, ma'am. Yeah, trapezoid is another one that belongs in the quad family. Quadrilateral. And there's one more you guys have forgotten. That's actually the quad. That's the name of the family. Okay, who could think of the other one? There's one missing. Kind of looks like this. Okay, now he gave us a new term. He gave us another polygon, hepta. That's excellent. So that was 6, and this is probably what? Well, there's something in between there. I forgot it. Here's 5 side. Okay, but a heptagon is actually 7 sides. Okay, what's a 5-sided polygon? Penta? Is that what you said, Devin? I didn't hear you, but good job. Penta. Okay, hepta. Stop sign has 8 sides. What is it? Octagon. Okay. All right. So see if we're jog you guys' memories today, because when we do geometric probabilities, we talk about all these basic things. How about a 9-sided polygon and a 10-sided polygon? What are the names for those? This is a nonagon.
Whoa, I was right.
Why does that surprise you? All right. Yes, ma'am. 10 is a decagon. 10 is a decagon. Okay, 10 is a decagon. Okay, so that's a by the way. We wanted to add those things since we're talking about basic shapes. I think in your assignment we only deal with basically rectangles and circles, and maybe a couple of triangles. Okay. Side note, no one gave me this shape. This is the last one of the quadrilaterals. Might look that up. That might even be in your planner. Begins with a P, that's all I'll say.
Parallelogram.
It is a parallelogram. Good job. The hint worked. Okay. Good. Now, here's our question. We want to know the probability of landing in the shaded region on this problem. Landing in the shaded region. All right, probability of landing in the shaded region. So we have 2 tasks here. We have 2 tasks. All right. We have to find the area of the triangles, and we have to find the area of the rectangle. Okay. Now, let's take the easy one first. Okay, the easy one first. All right, what's the area of the rectangle? That one's the easiest one to pick out and to figure. What is that? Yep. It's 4 times 12. Thank you. Somebody have an answer for me? Thank you. And it doesn't give us a unit, so I'll just put unit squared so we know we're talking about area. All right. So that's the area of the rectangle. Now we have to find the area of the triangles, which is a slightly harder. All right. On the triangles, we have to break this down. What's the base of my triangle? That is 12. Okay, that is 12. Okay, so the base of the triangle is 12. So the half times base times height, that part is, the base is 12. So we have a half times 12 times. Now what's the height of the triangle? What's the height of the triangle?
4.
Okay, well, we have some ideas here. Somebody said 8, all right? And that's this length here, okay? But the height of what I'm talking about is right here. Somebody said 4. Okay, another possible dimension is 2. Okay.
6.
What I'm going to do is, someone said 6. All right, so there's some ideas. Somebody's brainstorming, okay? Now, does it have a dimension on the height, though? Is it listed? Is there, at the moment, is there a logical thing that we can state that fits the definitions of what a right triangle looks like? All right. Can we say that the height is, or this distance across this way is 12? Not necessarily. Okay, we can't assume that. All right. But there is a theorem that we could use to find that height that's not given. Okay, we could use that to find the height that's not given. Okay, and how can we go about doing that? How can we go about doing that? Who knows that? Okay, well, I'm looking at a lot of blank faces here. Let's look over here. What is this side right here? How long is that? From here to here. So we're looking at here to here. That is 6. Thank you. Okay, that dimension is 6. So I have 2 of the pieces of the right triangle. Okay, I have 2 of the pieces of the right triangle. I have 8 and 6. Okay, 8 is considered what out of the right triangle? On a right triangle, let's talk about a right triangle for a second. What are the parts of a right triangle? Do you remember them? What are the parts of a right triangle? Okay. Well, we have the legs, and we have what do you call the longest side in a right triangle? Longest side in a right triangle. You know what I'm talking about? Yes, sir. Nice job, the hypotenuse. All right, so the longest side is the hypotenuse. So I'm just putting right triangle parts. Okay, we have the hypotenuse. All right, and then we have the legs. Okay, the legs are a no-brainer, and that's why I just say that. These are the parts. Okay. Now, there's a theorem that allows us to calculate a missing part on a right triangle. Does anyone remember the theorem? Begins with a P.
That was a stupid answer.
All right, no, there's no answer that's stupid. You're brainstorming. How about the Pythagorean theorem? You guys remember that. You had this back last year somewhere. All right, Pythagorean theorem. All right, so that's a squared plus b squared equals c squared. Okay, so let's quickly find the that missing side. So I know the hypotenuse, that's 8 squared. I know one of the legs, that's 6 squared. I'm trying to find the height there, the other leg of the right triangle. So if I subtract these, okay, then I can find my missing leg of my right triangle. So this is going to be 64 minus 36. So I need some help there. 64 minus 36. Need some assistance on a calculator. Somebody, can you get that to me, please? It's 28. Good job. Okay, so that's 28. Okay, so now what do I need to do? To find the answer for A, I have to take the, how do you undo a square? Not divide, but take the square root. Thank you. So take the square root of 28. All right, so I need some assistance on that. What's the square root of 28? Square root of 28. Can everybody find that on their calculator? What did that come out to be? No. Take the square root of 28. Square root of 28. Square root's this symbol in your calculator. It's with the squared key. What? Okay, I think that, yes ma'am, 5.3. 5.3. Okay, so I'm going to go back up here. All right, I have this. This is 5.3. All right, that's 5.3. Yeah, that looks like 5 times 3. It's 5.3. Okay, 5.3 here. All right, we're going to multiply those together. So I need you to find the area of one of those triangles. So half of 12 times 5.3. I need you to find that quickly. Okay, so this came out to be, she says 31.8. Okay? That's the area of one triangle. So for both of them, it'd be what? So that wouldn't be squared, it'd be doubled, right? So that would be total up to what? I need some assistance on that. What would that be? 63.6? All right? So now when we go to our probability formula, we want to know the probability of landing in the shaded area. All right, so I'm going to scroll back up in my notes here. All right, scroll back up in my notes. All right, I'm going to put 63.6 here. All right, what's the total area? All right, how do you find the total area? The two triangles plus the rectangle, what would that be? So 48 plus 63.6, what would that be? Okay, so I need somebody to divide that out and find us what our probability would be then for landing in the shaded area. Probability of landing in the shaded area. Okay, you divide it backwards. If it's bigger than 1, you divide it backwards. I need another answer here. What? Okay, did anyone else get 0.56? Okay, good. So about 56% of the time. So 0.56 is your probability of landing in there. Okay, I got to stop. Your assignment's page 271. Page 271.